Hey everyone, well, we're off the blocks with a look at what is our first viable candidate for a true next-gen gaming platform. And it's not a console. In fact, with one small exception, there's no actual user-side hardware at all. If you've got a fairly modern PC, Mac, smartphone or tablet, you can play it. In fact, pretty much anything that decodes video will run this platform. It's from Google, it's called Stadia, and in this video I'm going to talk about how it has the potential to change everything. And the funny thing is, it's not really the traditional specs that really make this possible, but more on that in a bit. So what's the deal then? Well, essentially Stadia is a gaming layer that sits on top of YouTube. The Google video system remains the world's biggest platform for watching games, but the firm kind of wants to merge both watching and playing communities. Click a button to jump into the game you're watching, use YouTube live streaming or share links across the web, Facebook, WhatsApp or email to set up a multiplayer game and then boot it in 5 seconds. That's the vision here. You don't have a box at home. The gaming hardware sits in the cloud. That means a lot more convenience, so no system software updates, no patches, no game installs. Everything is instant, the way that gaming used to be, certainly on the consoles. There's no such thing as a free lunch though, and the trade is latency, the lag between sending inputs to the cloud and getting a response back, along with image quality. The pristine HDMI link between source and display is replaced with a compressed video stream, but that will go up to 4K 60 frames per second HDR. Meanwhile, because you're already on YouTube, you can live stream at the same quality to other users even if you yourself are receiving an SDR 1080p feed instead. Crazy, right? But there's more advantages to the cloud than speed alone. Much more. Okay, so consider a current-gen multiplayer game. I guess a standard example would be something like Apex Legends. A lot of players in that one for sure, but fundamentally, the richness of the experience is limited by bandwidth. Your console or PC running the game is far, far away from the server that's coordinating everything. And yeah, the kind of connection between client and server is very, very narrow. With a cloud system, the server and the client appears on the same massive network with a huge interconnect linking them. We get around 100 players on a Battle Royale game now, but with more tightly integrated server and clients, that could be hundreds or thousands, even more. More than that though, there is the concept of simulation quality. Have you ever noticed how worlds in multiplayer games are pretty static, how physics are pretty limited? There's only so much data that can be sent down the internet pipe. I mean, we all saw what happened with Crackdown 3, right? Those insane physics we were promised just never really happened. Not really. So that's a very brief overview of the potentially game-changing ways that Stadia could provide new, next-generation experiences. We've been promised the power of the cloud before, of course, but well, this is Google, a global mega corporation with more money than God. They're setting up a first-party game studio and they're commissioning platform exclusives, just like the likes of Microsoft or Sony would. And this really is the tip of the iceberg, because really what Google is promising, and I stress the word promising there, is much more. Yes, there is a hardware specification for client hardware, but it's also based around the concept of what Google calls elastic compute. More about that in a sec, but for the time being, let's talk core specifications. We'll start with the CPU, one of the defining limitations of current gen systems. Google isn't saying who is providing their CPU for Stadia, but let's just say that with the spec that's been released, it's pretty easy to figure out that AMD just don't produce anything quite like the configuration seen here. We're looking at an x86 processor clocked at 2.7 GHz, which is great, and we've also been told that it's many core in nature and does utilize hyperthreading. AVX2 instructions are supported, and there's the curious disclosure of 9.5 megabytes of L2 and L3 cache. Google also says that it's a server-class CPU. Really, what Google is providing for its system here is a true generational leap over the Jaguars seen in the current-gen machines, though how it compares to PC processors in the cloud space or at home remains to be seen. Next up, the GPU, and yeah, this one surprised me. Google has typically used NVIDIA Tesla hardware in its data centers, but instead, for Stadia, the company has gone with AMD. Now, I specifically asked about what architecture was being used, but no definitive answer was forthcoming. However, we do know that the GPU in question features 56 compute units, and total compute is rated at 10.7 teraflops. That's 78% higher than Xbox One X and a 5.8 times increase over the base PlayStation 4. But remember, compute isn't everything. This GPU will be much more modern in design than anything you'll find in a current-gen console. A quick back-of-an-envelope calculation suggests that the Stadia GPU is running at around 1495 MHz, give or take. We seem to be looking at a spec that's quite similar to AMD's RX Vega 56 then, albeit with a more stable clock rate. But yeah, as I said, Google isn't confirming architectural details at all. But maybe that explains this. In the week before GDC, Crytek revealed its own real-time ray tracing solution for CryEngine, and it uses no hardware acceleration at all. However, it is seen running on an RX Vega 56 out of all of the GPUs that Crytek could have chosen. So maybe there's some kind of hidden message for us here. Or, you know, maybe it is just a coincidence. Regardless, even if there is no hardware RT in the Stadia GPU, we do at least now know that a Radeon graphics core with equivalent compute can do real-time ray tracing. On top of that, Google has confirmed that the Stadia client setup has HBM2 memory, 16 gigabytes in total, which is shared between the CPU and the GPU. That's the total system allocation. This suggests a tight integration of the CPU and GPU, but the firm has also said that those components are not integrated in a single chip, an SoC, as is the case on current-gen consoles, and I suspect the next-gen ones too. The HBM2 memory is rated for 484 gigabytes per second of bandwidth, which is identical to the throughput of the Vega 56, which uses a wide 2048-bit memory interface with the HBM2 running at 800 MHz. Further specs on Stadia's memory setup should prove fascinating if they are released further on down the line, but this setup of sharing HBM2 across CPU and GPU is certainly the first example we've come across. Our final spec point concerns storage. First of all, let's talk speed. Server-class SSDs are used here, with the aim being to launch any game in 5 seconds, but we can obviously extend that out to advantages with in-game loading as well. Now, SSDs are expensive, which is fine for a data center, especially one built by one of the richest mega corporations in the world. But the point is that it's highly unlikely that next-gen consoles will have this level of speed. And as you see here, this is how Stadia running Assassin's Creed Odyssey compares to the Xbox One X version in terms of loading times. And you can see that there's a pretty big difference there. But perhaps more exciting is the fact that according to Google, every cloud instance has access to petabytes of SSD storage. So, in theory then, developers need not be constrained by the 50 or 100 gig limits of Blu-ray media. A petabyte is 1024 terabytes. Okay, so what's all this I was talking about earlier about elastic compute? Well, Google's talking about what I think is stacking that client hardware, expanding CPU and GPU power according to the needs of the developer. And apparently there's a demo they have showing 3 GPUs running in concert. The aim is not to limit the scope of games by hardware limitations, but there must be some way that all of that client hardware interfaces, so I'm going to be really interested to see how game makers can utilize that. Google tells me that this elastic compute is available both to dedicated servers in the cloud that might require a ton of resources, and it's also available to the clients where, GPUs can be stacked there, which is absolutely fascinating. Another aspect of the Stadia proposition is the controller. Here's a pic of it, and I've had the opportunity to use it. What's interesting about it is that it's actually Wi-Fi based, so you have a direct link from the pad to the cloud without needing to go through client hardware. It's not exactly oozing with character, is it? But I found it perfectly functional, and in the hand it actually feels very much like an Xbox One controller. Even the plastics feel kinda similar to the Xbox One S controller. There are two extra buttons here, one for addressing the system via Google Assistant, and yes, the pad obviously has a microphone, and another for sharing. There's a USB-C, so you can use the pad with a computer if you want. But one of the reasons Google has made it is because Living Room Play is achieved using Chromecast connected to your HD TV, and that has no controller input capabilities of its own. A quick word on system performance, because I did have the chance to go hands-on with a more recent version of Google Streamer. Yes, we've already looked at Project Stream, the beta, back at the tail end of last year. And once again, Assassin's Creed Odyssey is the game being demonstrated, meaning that although I'd rather see something new, we can at least compare. Google is promising 4K HDR streaming for those with super meaty connections, but the game is still running with a 1080p video stream on this test. And just like Project Stream, performance is still 30 frames per second, not the 60 frames that would reduce lag by around 33 milliseconds. And 1080p 60 on this game would be well within reach of the Stadia spec based on the PC version. Image quality seems to be slightly better than the Stream beta, but mostly around the same, which is to say not pristine by any stretch, but not bad. I actually found the sweet spot for image quality when I played on my MacBook Pro 13. The smaller the screen, the smaller the artifacts. And I also played on a smartphone, the issue there being that the UI is rather tiny and difficult to follow. For latency testing, I used a 240 FPS high-speed camera pointed at a Google Pixelbook. Now, we count the frames between button press and action on screen, and then stack it up against our existing Assassin's Creed Odyssey results from the stream period. Now, the thing is, this Pixelbook is using Wi-Fi to connect to the internet, which incurs extra lag versus the LAN connection we used for stream testing. And with the Pixelbook, we don't know its display latency either, which adds another unknown variable. Okay, so look, this was on a Google internet connection, so not control conditions. So bear that in mind. And in prior stream lag analysis, we used a 200 megabits per second hookup. Regardless, this new Stadia result, even with Wi-Fi and display lag, is 13 milliseconds faster than our prior result from Project Stream. If we factor display lag back into our old measurements, 21 milliseconds on an LG C8, well, the picture changes. It looks like this. The gap closes and Stadia is actually on par with Xbox One X being played locally. Something else interesting is that Google has an option for developers to test using far from ideal internet conditions, a subpar 15 megabits per second connection. Latency increases, as you can see in the table here, and actually when you're playing, the resolution of the stream drops to 720p. Now, this is far from ideal, but this tool for game makers is kind of designed to simulate a worst case scenario. Now, I did have a go on this and it is still playable, but yeah, it does incur additional latency, as you can see. So let's sum up then. The specs are impressive and the integration at the cloud level opens up a lot of opportunities we've never seen in gaming before. CPU and GPU power is a world apart from current gen consoles, and I'll be fascinated to see how this elastic compute concept works out. I do think image quality for a massive living room display needs some improvement, especially if Google does roll out 4K 60 streaming, but playing on the Pixelbook and on my MacBook certainly seemed to be a sweet spot of sorts, and it looked pretty awesome. Now, we'll have more on Stadia as and when we can, but do check out the links in the video description for more. Hopefully you'll find an interview with key Google staff there, along with more of my thoughts about the system. But that's all from me for now. Please do like and subscribe to support work like this. Ring the bell for instant notifications. And yeah, please do consider taking a look at the DF Patreon to support the team more directly and get access to pristine quality video downloads. But that's all from me for now. Hope you enjoyed this video and yeah, thanks for watching.